Hello everyone, welcome back to lesson number 30 for Calc BC, where we're all about volume. In this particular video, we're going to talk about volume of disc and washers as a review. So, first thing I want to do is down here in the very bottom, very colorful examples, you guys can see the formulas for if you want to rotate a shaded region in terms of an actual disc. This means that the shaded region that we create is going to be flush with our axis of rotation. So if we were to draw ourselves a little rectangle, it's going to be perpendicular to our axis of rotation. It's going to touch it. So if we're looking at anything horizontal, so the x-axis or any y equals number, then we're going to rotate in terms of x. So the a and b are going to be our left and right hand bounds, and then our radius is going to be squared because, again, we're going to create ourselves a circle. So volume integrated is just going to be our area. And so when we create a circle, we're going to use the area. So it's going to be pi r squared. If I want to go ahead and rotate around a vertical axis, again, the y-axis, or x equals the number, it's going to be all about the y. We're going to, again, pull out the pi because the area of a circle is pi r squared. We're still going to have the radius squared. The radius is going to be our function, right? It's going to be our function. And then it's going to either be the axis of rotation minus our function or the function minus our axis of rotation. We'll get that in a minute. And then our C and D is going to be our upper bound or our lower bound. So if, let's say, we are rotating around an axis of rotation that's not flush, and we actually create ourselves a hole or a gap or something, then we're going to have a washer. And so we do the same thing as before. If we rotate something around something horizontal, then we're going to, again, use everything in terms of x. Again, x-axis and y equals a number. We still have the same thing. We still have our pi. We still integrate from a to b, our left bound and our right bound of our region. Our big R squared minus our little r squared, dx. If we're rotating around a vertical axis, then it's going to be the volume equals pi. Again, this is our top and our bottom bounds. It's going to be our big R squared minus our little r squared. So let's go ahead and do our example. So I love this example as a review question because I'm going to do this and I'm going to rotate around all four of these lines, and they're done in a different way based on what we're rotating around. So first thing we're going to do is going to draw the picture. So it says consider the first quadrant region. So we're just in the first quadrant. So that's really awesome to know. Here's our x-axis, and here's our y-axis. And we're going to be bounded by y squared equals x. Well, that's the same thing as y equals the square root of x. We just need the positive root because, again, we're in the first quadrant. So we're going to go ahead and let me change the color up here. So we're going to go ahead and sketch, just roughly, the line y equals x squared, or y equals square root of x. We're going to also bound it by the x-axis, and we're going to bound it by the line x equals 4. So at x equals 4. So let's go 1, 2, 3, and then 4. So this is going to be our region right here. So this is what we're going to be shading in, and we're going to be rotating about. All right, so we want to rotate around the x-axis first. So this is where it gets a little interesting. So first thing I'm going to do is I'm going to look at this problem, and I'm going to rotate it around the x-axis, which means that, again, it's a horizontal line, so that tells me that everything's going to be in terms of x. So I always do that first. I always think about that first. So if it's in terms of x, I want my function in terms of x, so I'm going to use what I've written in purple. So I also know that if it's a volume, it's also flush, right? My rectangle is actually flush with my x-axis. So I know that I'm going to have just one r here, and the r is going to be the distance of this rectangle, or the height of this rectangle. So I'm going to always start out with pi. I'm going to integrate, because it's in terms of x, my left bound, which is 0, and my right bound is going to be at x equals 4. And so my top function is going to be the square root of x. It's going to be the square root of x, and I'm going to square it. So again, pi r squared. And technically, this would be the square root of x minus 0, right? The top function minus the bottom function ends up being 0, so we're good here. And then dx. So that's all we have to do to find that particular problem. Okay, so now we want to rotate around the y-axis. So we're going to go ahead and rotate around the y-axis. So again, since this is a vertical line, everything's going to be in terms of y. So I want this equation. Well, I want x equals y squared. So what I'm going to do with this one is I notice that there's going to be a gap here. So if I want to draw myself a rectangle, then, and I can absolutely do that, it's not flush. It's not flush with my actual axis. So I know I'm going to have a big R and a little r in this particular example. So what we're going to do is we're going to do pi, and we're going to do r. And so since this ends up being a actual terms of y, my lower bound, so y equals 0, but my top bound is going to be what's right here. What's this y value? Right? So what's the y value of this? Well, I know that x is equal to 4, right? X is equal to 4. Well, what's that going to be for y? Well, y is going to be equal to 2, right? The square root of 2. So I'm going to be bounding this from 0 to 2. I'm going to go ahead and get rid of this, so we can do that. Now, what is big R? Big R is going to be the distance from, and again, the axis of rotation is to the left of my shaded region. So if the axis of rotation is to the left, it's going to be the curve minus the axis of rotation. Well, the furthest thing from my axis of rotation is going to be my big R. Well, the curve that's to the right here is going to be x equals 4, right? This line is x equals 4. So big R is going to be 4 minus this function. Well, that's going to be x equals 0. So 4 minus 0, which is 4. And you guys can see that, right? That's pretty straightforward. This distance is 4 units. So that's going to be big R. So I'm going to go ahead and do 4 squared. Well, what's little r? Well, little r is going to be this distance. It's going to be the curve that's the closest. And again, these curves are what creates the shaded region. So it's going to be the closest curve, which we know is y squared, minus 0. And so this is obviously going to be y squared. So we're going to do minus y squared. Please don't forget that we have to also square this, and then we're going to be left with dx. Sorry, dy. dy, right? Let's go ahead and fix that. dy. Okay, so let's go ahead and look at what happens when we go around the line x equals 6. So x equals 6 is actually going to be over here, right? X is equal to 6. So we're going to revolve around the line x equals 6. And since this is, again, a vertical line, we're going to make everything in terms of y. So the good thing about this is that we've actually already done the first part. We actually already know it's going to be from 0 to 2. And so now we got to figure out what our big R is again and our little r. So big R is going to be, now again, this time the axis, and by the way, you guys can see that if I draw myself a rectangle, right, that's perpendicular to my axis of rotation, there's going to again be a gap here, right? There's going to be a hole. So we have a big R and a little r. So big R is going to be the distance from our curve to our axis of rotation. But remember, because we're in terms of y, it's always right minus left. So I want the right-hand curve, which is going to be 6, minus our left-hand curve, where our left-hand curve is going to be, again, y squared. So this big R is going to be 6 minus y squared. And so that's what the big R is going to be. Little r is going to be this distance right here. Again, it's always the axis of rotation and the curve that's closest to it. And so again, because the axis of rotation is on the right, we're going to do right minus, and our left-hand curve is going to be 4. And notice that all these equations were x is equal to, right? This was x is equal to y squared, x equals 4, x equals 6. So that's what we're going to do. And simply, ladies and gentlemen, we're going to go ahead and just take what our big R is, and we're going to quantity square it, and we're going to subtract our little r. And we all know that this is just going to be 2. So we're just going to go ahead and do 2 squared, and then dy. So I'm hoping that you guys are understanding that the axis of rotation, depending on where that is, we could be subtracting it from the axis of rotation or not. So if it's a change in y, if the axis of rotation is on the right-hand side, then it's going to be the axis of rotation minus the curves. If it's on the left-hand side, then it's going to be the curves minus the axis of rotation. If I'm doing it in terms of x, then if it's above the curve, it's going to be, again, top minus bottom. So it'll be the axis of rotation minus the curve. And if it's below the curve, then it's going to be the curve minus the axis of rotation. I know that was a lot of talking, and I hope that makes sense for you guys. All right, so now what we're going to do is we're going to look at our final example here where it says the line y equals 2. So line y equals 2 actually ends up being right here. So like before, we're rotating around a horizontal line, so everything's going to be in terms of x. And so we can kind of steal from the first part up here that's going to be pi, and we're going to integrate from 0 to 4. So you guys can see that if I draw a rectangle perpendicular to my x rotation, it is not flush. It's not flush with my curve, so I have to do a big R and a little r yet again. Well, big R is going to be, now again, the axis of rotation is above the curve. It's always top minus bottom. So I'm going to use the fact that this is going to be y equals 2, and so it's going to be 2 minus the curve that's the furthest away. Well, the curve that's furthest away is going to be y equals 0, or the x-axis. So this is going to be 2 minus 0, which again, you guys can see that this distance is 2. Little r is going to be the axis of rotation, and it's actually going to be this distance right here, right? It's going to just be whatever the axis of rotation is minus the curve that's the closest to it. So again, y, which is our top curve, and then our it's our axis of rotation, and then the curve that's the closest to it is the function. Again, everything's in terms of x, so we want to use this right here. So it's going to be the square root of x. Okay? So all we do now is plug in what we have. So it's going to be 2 squared minus 2 minus the square root of x quantity squared dx. And that's how you set up all of these problems. So those are the answers. If you plug them into your graphing calculator to verify you got them right. A couple of these questions you could actually do without a graphing calculator, to be honest. I mean, the part A and part B you could easily do, and even part D. You could do these without a calculator easily. I mean, the other one, C, you can do as well. But I hope that really helps you guys. I think this is a good example to show you that really, if it's a change in X, it's always your right minus your left. And then for change in Y, it's going to be your top minus your bottom. So I will see you guys in the next video where we continue on with the wonderful world of volumes. Take care.